Welcome, dear students, to one of our new math sessions. Today we'll be talking about the properties of cyclic quadrilaterals. Theorem 3. In a cyclic quadrilateral, each two opposite angles are supplementary. And remember, what are supplementary angles? Are the angles where their sum is 180 degrees. So, if you can see here, how can we prove it? Measure of angle A plus measure of angle C, there are two inscribed angles. So their measure is equal to half the sum of the two arcs BCD and BAD. So measure of angle A plus measure of angle C equals half measure of angle BCD plus measure of angle BAD. So it's half 360, which is 180 degrees. This proves our theorem that in any cyclic quadrilateral, each two opposite angles are supplementary. Let's move on to example number 1. In each of the following figures, find the value of the symbol used in measuring. So in question number 1 and also in question number 2, the question wants us to find the values of x and y. Let's go to question number 1 and see how can we find the value of x and then for y. As long as this is a cyclic quadrilateral, so the measure of angle A plus the measure of angle C equals 180 degrees. So here, angle A, which is the 4y, plus angle C, which is the 5x, is equal to 180 degrees. So as you can see here, we have two variables in one equation, so we have to pause and check the other two opposite angles. In the other two opposite angles, you will see that the measure of angle B plus the measure of angle D is also 180 degrees because there are two opposite angles in a cyclic quadrilateral. So 107 plus 2x plus 7 is equal to 180. To solve this equation, 2x is equal to 180 minus 114, so x equal 33. After you get the value of x, which is 33, you go and try to find y. So you substitute x by 33. So you will see that y equal 15 over 4. Let's move on to question number 2. As you can see here, ABCD is a cyclic quadrilateral. So each two opposite angles are supplementary. Then x plus 15, which is angle B, plus angle D equals 180, then x equal 50. After finding x equal 50, we go to the other relation. You will see that measure of angle A plus measure of angle C is equal to 180, then 2 times 50 plus 2y equals 180, then 2y equals 80, after that y equals 40. So the value of y is 40. Let's go to example 2. Another example, ABCD is a quadrilateral inscribed in circle M, where M belongs to AB, where CB equal to CD, and the measure of angle BCD equals 140 degrees. First question is asking you to find the measure of angle A. As you can see here, ABCD is a cyclic quadrilateral. Therefore, the measure of angle A plus the measure of angle C, the two opposite angles, are supplementary. So the measure of angle A plus measure of angle C equals 180 degrees. Then, measure of angle A equals 180 minus 140, which is 40 degrees. Let's now draw BD segment in triangle BCD. As long as CB is equal to CD that was given, therefore, the measure of angle CDB is equal to the measure of angle CBD, which is 180 minus 140 divided by 2, so each is 20 degrees. And as you see that AB is a diameter, so angle BDA is an inscribed angle, and its subtended arc is the semicircle, so the measure of angle ADB is 90 degrees. So if the question is asking us to find the measure of angle D, then the measure of angle D is 90 plus 20, which is 110 degrees. Let's move on to one of the corollaries. The corollary says the measure of the exterior angle at a vertex of a cyclic quadrilateral is equal to the measure of the interior angle at the opposite vertex. The measure of the exterior angle, which is here in this case, is angle CBF. It's an exterior angle at a vertex of the cyclic quadrilateral. It will be equal to, where's the opposite interior angle? Yes, angle D. So it will be equal to the measure of the interior angle at the opposite vertex. ABCD is a cyclic quadrilateral where E belongs to ray AB and does not belong to segment AB. E is outside the circle. Therefore, angle EBC is an angle outside the cyclic quadrilateral ABCD. Then, as we said, the measure of angle EBC is equal to the measure of angle D. Let's go and see another example. Here, E belongs to AB ray, and E does not belong to segment AB. So E is outside the circle. The measure of arc AB is 110 degrees, where the measure of angle CBE is 85 degrees. How can we find the measure of angle BDC? As long as the measure of arc AB is 110 degrees and angle ADB is the inscribed angle with arc AB, then the measure of angle ADB equals half the measure of arc AB, which is 55 degrees. Since CBE is an exterior angle at a vertex of the cyclic quadrilateral ABCD, then the measure of angle CBE equals the measure of angle CDA, which is 85 degrees. So the measure of angle BDC is 85 minus 55, which is 30 degrees. Let's now check the converse of theorem 3. If two opposite angles of a quadrilateral are supplementary, then this quadrilateral is a cyclic quadrilateral. So you will see here that if measure of angle A plus measure of angle C equals 180 degrees, or if measure of angle B plus measure of angle D is 180 degrees, then ABCD is a cyclic quadrilateral. Let's see example 3. In each of the following figures, we need to prove that ABCD is a cyclic quadrilateral. Let's go to question 1. Okay, in triangle ABC, we can easily get the measure of angle B. Measure of angle B equals 180 minus the sum of 35 and 50. Which is 95 degrees. If we add angle B with angle D, you will see that the measure of angle B plus the measure of angle D, these are the two opposite angles, is 85 plus 95, which is 180 degrees. Then, if opposite angles are supplementary, then ABCD is a cyclic quadrilateral. Let's check question 2. AD is equal to DC as given. Therefore, the measure of angle DCA is equal to the measure of angle DAC is equal to 40 degrees. So here, this one is also 40 degrees. So we can easily get the measure of angle D, which is 180 minus the sum of 40 and 40. Which is 100 degrees. So this angle now is 100 degrees. So if you check angles B and D as they are opposite angles, you will see that the measure of angle B plus the measure of angle D, which is 80 plus 100 equals 180 degrees. So this proves that angles B and D are supplementary angles. If the two opposite angles are supplementary, then ABCD is a cyclic quadrilateral. Let's see another corollary. If the measure of the exterior angle at a vertex of a quadrilateral is equal to the measure of the interior angle at the opposite vertex, then this figure is a cyclic quadrilateral. So here, if angle EBC is equal to angle B, if the measure of angle EBC is equal to the measure of angle D, then ABCD is a cyclic quadrilateral. Let's move on to example 2. In the opposite figure, as you can see that angle ABE is given that it has a measure of 100 degrees, and angle CAD is given that it has a measure which is 40 degrees. How can we prove that? Measure of arc CD is equal to the measure of arc AB. You check it in here, you will see that the measure of angle ADC is equal to the measure of angle ABE. is equal to 100 degrees. So angle ADC as well is 100 degrees. Okay, so now we can easily get that the measure of angle DCA is equal to 180 minus the sum of 140. So the measure of angle DCA is 40 degrees. So we'll see that AD is equal to CD. So therefore the measure of arc CD is equal to the measure of arc AD. Another exercise, find the value of the symbol used in measuring. The question here wants us to find the value of x and the value of y. As you can see here, quadrilateral ABCD is a cyclic quadrilateral. As long as it's a cyclic quadrilateral, then the opposite angles are supplementary. So here in this case, angle A is equal to angle C, so x equals 35. So here, to find the y, you will see that the inscribed angle DCB, its arc is DAB. To find y, you will see that angle C as an inscribed angle, its arc is DAB. So the measure of arc DAB is double angle 70, which is angle C. So the measure of arc DAB is 140 degrees. As long as CA is a diameter, so the measure of arc CD is 180 minus 140, which is 40 degrees. So to find y is the intercepted angle for the arc ADC, where AD is half the 140, which is 70. So the measure of angle ABC is half arc ADC, which is half the 70 plus the 40, which is 55. So y is 55. By finishing this exercise, we came to the end of our session. Thank you very much.